Okay, so RL circuit, there's the equation. There's a EMF function. And we can call that function of t if we wish. And we're going to let the EMF function be just some Vmax cosine omega t. Okay? However, in addition to this, surges occur periodically. And something in our system is just causing a surge that occurs with some frequency. Okay? And we're going to assume a frequency much less than the frequency of this. So that this will go through a lot of cycles before you hit a surge again. Okay? So what's going to happen, the surge is going to disrupt your circuit, or your current, but then it'll come back to where it ought to be before you hit another surge. Of course, we can mess with the frequency of the surges, make them more frequent so that it never does come back to where it should be, and then ask the question, what happens? Okay? Now, I don't know how far we'll get with these questions, but that's kind of what we're looking at. Okay? So surges appear periodically. Let's model surges first, not by a delta function, but eventually we will, but by some surge voltage for some time delta t. Okay? And let's say those surges occur at time capital T, 2 capital T, 3 capital T. And well, then what's our source function, or our driving EMF, is going to be this. Okay? Where you have the V surge delta T times H of big T plus delta T minus H of big T. Now let's think about what that means. Okay? And before we actually get into this, well, okay, here's T, right? So here is H of big T. Now, we've already done this, but we haven't used it that many times, so let's, okay, so here's H of big T. I'm going to make this H of big T plus delta T. So here's T plus delta T. The reason is that the H of T is going to be minus H of T. So here's T, and your H of big T minus delta T is, or your H of minus H of big T is this, right? So that our function is just add these two together. I got that backwards. I should have done H of big T minus H of big T plus delta T. I'm going to stick with this. Why the heck not? You can have a negative surge. Okay? All right. So it's just this, right? So you just have this kind of surge function here. Okay? And since V surge could be positive or negative, we could still make this positive. Okay? So I screwed up the sign when I did that, but I'm not going to go back and change it. It works just as well one way as the other. Okay, so this means that we have like our source voltage come along here, and then all of a sudden we've got a big old surge. Okay, it comes down here, and it's still going to kind of do a little of this, but it's not going to have time to do much. It's pretty much just going to be constant down here, because it's probably going to be a shorter time interval than this, and probably a bigger surge. But then our voltage just comes back to where it would have been. And then it goes on, and there's another surge, and there's another surge. And axis is here, okay? So this would be like our EMF function, okay?
Right.
So for this particular function, of course, we only have one surge. So let's just see what happens with one surge. Well, let's go ahead and do Laplace transform. See if you can Laplace transform that equation.